So just to refresh your memory about how to find a reference angle, um, we've got to remember you decide what quadrant the angle falls in, and then you draw that reference triangle. You will always come back to the x-axis. So if you're here in quadrant one, you bring that vertical line back to the right x-axis, and there's your right triangle. If I'm over here in quadrant two, back to the x-axis, there's that right triangle. That's your reference angle. Down in quadrant three, and so on and so forth. Always go back to the x-axis. The mistake that some people will make is they'll go to the y-axis, and that's not the reference angle. Okay, so I think you got that looking at the homework that you did. Um, so then how do you decide on the reference angle? Now, you got this right, so I'm assuming you came up with some way to do it. If here's in quadrant one, the reference angle is the angle given. I mean, because that's going back to the x-axis. If I'm over here in quadrant two, that's going to be pi minus the reference angle, right? So if I have an angle of 2 pi over 3, if I want to find that reference angle, pi, which is 3 pi over 3, minus 2 pi over 3 is going to be 1 pi over 3, or pi over 3. Okay? Down here, I'm going to do the angle minus pi because it's bigger than pi radian. So if I have 4 pi over 3, well, that's more than pi, and I know it's down here in quadrant 4. So if I take the angle minus pi, which is 3 pi over 3, that's going to be another 1 pi over 3 reference angle. And if I'm over here, I'm going to do 2 pi minus the angle. So this will always work in radians. If you're dealing with radians and degrees, you have to change it up a little bit. But so ask yourself what quadrant the angle falls in, and then you do this subtraction. And if of course, then if you have something that's going, like if I asked you to find the reference angle for something that was like 13 pi over 6. Or let's do something bigger than that. How about if I do um, uh, 47 pi? Here, let me get a marker going. What if I go 47 pi over 6? So I know that's going to have, let's see, what's that going to be? That's going to be 7 full rotations. So 42 pi over 6 is 7 rotations, right? 7 pi. No, sorry, I didn't do that right. That would be, let me make it up here. Well, let's do this one. Let's see. So I know if I'm in terms of 6, that's going to be 12 pi over 6 is 2 pi. 12 pi would go into that. If this was 48, it would be four full rotations. So this is only going to be 3 rotations. So I'm going to subtract 36 from that. 36 pi over let's see, over 6, right? Because that would be 12 pi, which would be 6 rotations. Yeah. So that would give us what's left over, 11 pi over 6. So that would be the angle that's coterminal to this, and that would put it down here in quadrant 4. So that would be 2 pi or 12 pi over 6 minus 11 pi over 6. That reference angle would be 1 pi over 6, wouldn't it? Pi over 6. Okay, let's go on and look at some more out of the book. I mean, these are all nice out of the book because these are just one rotation, right? So I mean, you could almost look at the unit circle, but let's say I wanted to find the reference angle for 7 pi over 4. Well, I know that that's going to be, well, let's see, this is going to be 2 pi over 4. This is going to be 4 pi over 4. This is going to be 6 pi over 4. This is going to be 8 pi over 4. So 7 pi over 4 would fall here in quadrant 4. So if you think back to that shortcut I gave you, 2 pi minus 7 pi over 4 would be 8 pi over 4 minus 7 pi over 4, which would be 1 pi over 4. And maybe you don't even need to do that subtraction, but that's how it works. So what about if I asked you things like find the reference angle of now what quadrant is going to fall in, and here, let me change slides here. So recording good. So what if I want you to find what quadrant does 2 radians fall into? Well, I know there's now no pi units on that. So then you got to start thinking about the decimal equivalents. Well, pi over 2 is something like 1.7 or something like that. Um, maybe it's a little more than that. Pi would be 3.14. So I know that a radian measure of 2 would fall here in quadrant 2. And then how do I get that reference angle? Well, I know it's going to be pi minus 2 because that's what we did. Now, if you wanted to get a decimal equivalent, you could say 3.14 minus 2. So that would be about equal to 1.14 radians would be the reference angle. Okay. What if I asked you to find here, let me erase all this. Delete, delete. Here, what if I asked you to find, um, here, so here's the angle. The angle is going to be theta 7. Let's figure out where that falls and what the reference angle would be. Well, I know that 2 pi is about 6.28. So this one would be, what, 7, um, 7, almost 8, right? That would be almost 8 radians would be back up at 90 degrees or pi over 2. So that tells me 7 radians would fall in quadrant 1. So then, because that's more than one rotation, right? There's more than one rotation. It's still in quadrant 1 though. So we got to figure out what angle is coterminal to that. So pi 7 minus 2 pi would be the angle that's in quadrant left over in quadrant 1, and that would actually be the reference angle. And again, if you wanted to get a decimal equivalent, 7 minus 6.28, and that would be what? 0.72 radians would be the decimal equivalent of that reference angle. Because remember, in quadrant 1, theta is the reference angle, except you got to break it down to between 0 and 360, right, or between 0 and 2 pi. Does this give you enough what you need?